Hello, we're talking about absolute value. We're going to lead this into absolute value equations. We're going to talk about polynomials and non-polynomials. But let's start with the definition of absolute value. A couple of definitions here. The magnitude of a real number without regard to its sign, or how far a number is from zero. So let's look at a couple. I mean, the absolute value of point A is 1, 2, 3. Now, the coordinate of point A is -3, but the absolute value of A is 3. So we could do this on a number line, and we will. We just said that the absolute value of point A is 3. And again, this is how far is point B from 0. That's the absolute value of point B, 1, 2, 3, 4, 5, which is 5. So it's just a distance. Don't make this thing hard. It's just a distance. And let's throw that into a question. You might want to pause the video and see if you can answer that. Give yourself a second. But that's the answer, the absolute value. There's 2 points here, C and B, that would satisfy the coordinates, and you're using their coordinates. The coordinate of C is -4. So if we were to substitute that in there, then obviously B is 4 space. It's just how far is a number from 0 on a number line. That's the concept of absolute value, which is a distance. So which means that doesn't make any sense. Why doesn't that make any sense? Because we're saying negative, what numbers or what numbers are -5 spaces from 0 on a number line? That doesn't make any sense. So anytime you have a negative number on the other side, it doesn't make sense. It's not defined. And that will come up. Okay, negative distance is not defined. Okay, so here's an interesting question. It gets better. Might want to pause the video, see if you can answer that. But, the short answer is here that it's A and F. And so you could plug those, and if I were to take the coordinates of F and plug it in, it'd be 1 plus 2, absolute value of 1 plus 2 is 3. And then if I were to do the same thing for, if I had to take that 1 out and put in -5, then I get a true sentence as well. Now, we could do this thing as transformations. We could say, okay, that the center is no longer 0. It transformed to the left too, but the transformations rules get really tricky after a while. Once you start adding stretches and shrinks and reflections, we really don't want to do that. All right, so let's talk about what's polynomial. We've spent a lot of time. We can solve every polynomial equation that there is. So let's recognize that, all right? You might want to pause the video and see if you can recognize that, but I'll go ahead and recognize them. That is polynomial degree 1, not because of the variable on bottom, not. So there's only one polynomial equation here. That's kind of what we're studying. We're taking non-polynomials equations and making them polynomial. Because if they're polynomial, they're so much easier to solve. That's why I keep emphasizing that. Okay, so let's get back to what we're doing here. Instead of using transformation rules, let's use the definition of absolute value to make polynomials. Well, one of them is, and the definition is that it doesn't matter if it's positive or negative here, that you get a solution. All right, and so the other equation would be that, where you take this value and you make it negative. Now, sometimes I will distribute the negative like I've done here, and sometimes I will divide both sides by -1. So just, be looking out for that. All right, the definition, let's look at this problem. The definition of absolute value can't be used initially here. Why? Well, it's because it doesn't, you can't use the definition of absolute value until you isolate the absolute value or the part that is not polynomial. So we would just want to simply add 10 to both sides and get that. And then once we do that, then we want to make our two polynomials. Well, one of them would be the inside positive. Oops. X minus 1 equals 6. And then the other one would be the inside negative, because the definition of absolute value means that it doesn't matter. I mean, the simple definition is that it doesn't matter, that the inside of the absolute value could be positive or negative. And then we would get 7 as a solution. And then if I distributed the negative and solved, that would be negative x equal 5 or x equal negative 5. And we might want to plug those back in. I mean, 7 minus 1 is 6. If we were to take, it's pretty bad, negative 5 right there. Let me rewrite that. Whoops. X equals negative 5. And then if we were to take that and plug it in, you would plug in negative 5 minus 1. And you would get negative 6. Then you'd take the absolute value. Okay. You got to be careful here, because now what you should recognize is that the right side, or the polynomial side, is variable. But let's just continue on like, those would be the equations. Went ahead and made them and solved them. That, this is the positive side. Change color, positive side. Here's the negative side. In this case, instead of distributing the negative, I decided to go ahead and just divide both sides by negative 1. Sometimes it's just easier to do that. And you need to be flexible. All right. So, but then we got to play the game of, okay, let's slow down and read here. Got to make myself slow down sometimes. Be careful. When the polynomial side is variable, the result should be substituted to identify extraneous solutions. In these problems, there could be one solution, two solutions, or no solution. And you just have to be flexible and be able to take each problem as it is. So you should be able to see that the negative 1 is not a solution. I mean, let's actually substitute this time. All right, and so I'll go ahead and do that. I'm going to take the 3 solution here and plug it in. So it'd be 3 plus 3 equals 2 times 3. Clearly, you can see that that's right. You'd get absolute value of 6 equals 6. That's true. Work it until you see that it's true and like, oh, okay, that's a solution. And then let's plug in the negative 1. So it'd be 3 plus negative 1, absolute value, equals 2 times negative 1. So that'd be absolute value of 2 equal negative 2, and that's false. We would have to reject that as a solution and say in this problem that there's only one solution. That's going to come up again and again. You're just going to have to be flexible, and especially, again, you really have to focus when the polynomial side is variable. Then you're really going to have to set, because again, you're either going to get no solution, one solution, or two solutions. They can both work. And again, you just have to be flexible. So let's see. Let's do an assignment and see how you do.